Okay, this is part 7 of our series of HVAC schematics. Now, we're still going to work with line voltage circuits for the moment because they're actually working on one level of voltage or line voltage. We don't have to worry about a transformer. We don't have to worry about low voltage control. And it's the basis of refrigeration. We have a line voltage, everything in it is line voltage, and we're controlling different components with other line voltage components. So in the last schematic, we took an evaporator fan motor, which was a shaded pole, and we let it run constantly. Then we had a cooling thermostat controlling a PSC motor, and that PSC motor could be a compressor, could be condenser fan, could be a pump, could be anything, okay? But the purpose is we had one motor running constantly, and we had another motor controlled by a thermostat. So in this circuit, we're going to build upon that, but we're going to change it up a little bit. This circuit is a typical circuit that might be found inside a reach-in, okay? Or, for example, one of those glass-fronted flower coolers that doesn't have to cool really low, but has to control humidity and cool right below room temperature to keep the flowers cool. Okay, so going down our parts list, I see that I have 5 motors. Everything is 120 volts. And then I'm being told that the line voltage thermostat controls everything. So now this has changed something up, okay? I no longer have a consistently running evaporator fan motor. So we still have a 120 volt circuit. It's still one circuit. So let's go ahead and draw our lines in for our first. We'll come over here. I'm going to do neutral. Okay, and I'm going to give myself plenty of room on this one. Okay, and then I'm going to come over here. I'm going to give myself room for my circuit breaker. Make sure I come to the same level. Okay, I'm going to put in my circuit breaker there. Okay, I'm going to go ahead and label everything while I'm here. Line, neutral. I'm going to put my label over there this time because I need the space inside. And I'm going to label 120 volt just so that we know what type of circuit this is. Okay, so I have the basis of my circuit. Now, the key here is that we also have a thermostat that controls everything. Okay, so I can come over here to my schematic sheet that I made. Remember I made this schematic sheet? And I'm going to copy this thermostat, my cooling thermostat. And I'm going to come over here and paste that. And I'm going to put that right there, and I'm going to decrease it a little bit in size. It doesn't have to be that big. And I'm going to label that before I forget. Again, I don't want to forget labels. Now, the other thing that I'm going to do is I'm going to come down here, and I don't need that wire anymore to be this long. Okay, because I really only need it to be the size of to connect the cooling thermostat, because everything else is going to come off that cooling thermostat. So I'm going to come out of that cooling thermostat. Okay, so all of my other components can fit in here. So let's take it from the top. I need a shaded pole motor. Okay, we know a shaded pole motor only has one winding. So I'm going to take my shaded pole motor. I'm going to take and copy that. I'm going to come over here to the schematic I'm drawing, and I'm going to put in my shaded pole motor. Okay, again, I know a shaded pole motor only has one winding. And I'm going to, before I go any further, I'm going to connect that in. Okay, and I'm going to label it. Okay, now EFM2 is a split phase motor. So a split phase motor, if we remember back to the motors conversation we had, it has 2 windings and a centrifugal switch to pull those windings out. So I'm going to come over here. I'm going to grab my split phase motor. I'm going to copy it. I'm going to come over here. And again, it makes it really, really big. And I'm going to take my split phase motor. Now that's just the motor. I still need the switch. Remember, the switch is that normally closed contact. So I'm going to copy that. By the way, you notice what I'm doing here is I have all my components all made. So it becomes very easy for me to basically cut and paste them in. Okay, so now I have my split phase motor. Let's go ahead and connect that in. Okay, let's label that because that has to be EFM2. Okay. So now I have my split phase motor, EFM2. And that's a centrifugal switch. No start components on that other than that switch. That switch will open when the motor reaches about 75% of its rated RPM. CFM1, which stands for condenser fan motor, is a PSC motor. Okay, so again, if I come over here to the schematics I drew earlier, I'm going to take my PSC motor. I'm going to copy it. I'm going to come back over to the schematic sheet I'm working on. I'm going to paste this in. Now I'm just going to off-center this a little bit. So actually, you know what? I'm going to off... Actually, we'll leave it there. So my CFM2, I'm going to come over here. And now I just have to connect. Let's go ahead and connect my... Okay, so again, remember, everything is still off my cooling thermostat, but everything is getting full source power because, again, we cannot put loads in series. So here's my CFM1. Okay, again, let's make sure we label it. Okay, now CFM2 is a CSIR. Remember, capacitor start, induction run. So this will have a start capacitor and some sort of starting component. So coming back over here, we see my motor that has my current coil relay in it. Okay, and a start capacitor. So again, I'm going to come in here. I'm going to just move that a little bit. I'm going to copy, oops, that isn't what I wanted. I'm going to copy that, come back over to my current diagram. Okay, so CFM2, I'm just going to label this before I draw the lines in, just so that I don't lose sight of the fact I got to label it. Okay, so now I got to connect my common to neutral. Okay, so that's CFM2. So going back up to our diagram, okay, EFM1 is my shaded pole, single winding. EFM2 is my split phase, start and run winding. However, it has a start component, centrifugal switch in this case, to take out that start winding. PSC motor has a run capacitor that's always in the circuit. CSIR motor, which is my CFM2, has this is a current coil relay, coil in series with the run. It's one of the few cases we'll see a coil in series with another load. And the only reason is because this coil doesn't use any voltage, basically. It's all based on current. And if you look at it, you'll understand why. The relay coil is very, very large. There's going to be no voltage drop on it. It's all current based. And then I have my start capacitor that's there as well. Okay, now the only thing I'm missing that my circuit is asking for is the compressor. Again, part of the refrigeration cycle, we have to have a compressor. Okay, so my compressor is a CSCR motor, 120 volt. Okay, so if we take a look at CSCR motor, CSCR has a capacitor start and a capacitor run. Okay, so I'm going to come over here and I'm going to copy. Actually, I'm going to move that run down a little bit so that I can see actually where that's at. And I'm going to copy that motor and I'm going to bring it over here. And that almost ended up in the right place. Now, this component at the bottom here, the 1, 2, and 5, that is a separate component that's wired in. Okay, if you want to, you can actually throw a box around that. Let's go ahead and we'll pull that line size down a little bit. Okay, and that shows that it shows that it's a single component. Okay, with 1, 2, and 5. 1 is wired to my start cap, which is wired to my line. 2 is wired to the start winding. 5 is wired to the common. Okay, so this I'm going to go ahead and label real quick. It's my compressor. Okay, and I'm going to then go ahead and connect this in. Okay, I want to select line again. Okay, so let's look at our schematic. Let me reduce the size so it can all see on one page. Okay, what we have is we have a shaded pole motor, a split phase motor, a PSC motor, a capacitor start induction run. I have my compressor, which is a CSCR motor. They are all controlled by first a breaker and then a cooling thermostat that's a close-on temperature rise. Okay, now here's sequence of operation. Once the circuit is energized, the cooling thermostat closes, energizes EFM1, energizes EFM2, energizes CFM1 and CFM2, energizes the compressor. Once the cooling set point has been reached, cooling thermostat opens and de-energizes all my loads. This is a cooling, again, this is a standard cooling circuit that you will find in like a flower cooler or a more of a medium to high temperature piece of equipment where we cycle the evaporator fans on and off. By the way, the trainers in the Porter and Chester shops has, for the most part, 2 EFM motors if there's 2 motors on the evaporator fans, and they'll be shaded poles.